Good morning, good afternoon, good evening, whenever you're watching this video. I hope you're doing well. Over the next couple of minutes, we're going to be talking about the volume of prisms, and I'll be honest, for the video that I'm going to make up over the next couple of days, the videos I'm going to make up, this is probably the most detailed video. Now, you may be thinking to yourself, I've done volumes of prisms before. It shouldn't be that difficult. Well, it's not difficult, but the type of prisms that we're going to be working with make it a little more detailed. And so, of the videos that you'll be watching this week, this will be the one that will take the most time. So I kind of apologize for that, but this, again, sets the groundwork for what we're going to be doing from here on out. And so if you take a look at your worksheet here, 10-5A, we can actually derive the formula for the volume of a prism by doing the very first problem here. And you may be thinking to yourself, oh, that's simple. It's going to be volume is length times width times height. And you know, I'm grateful that you know that formula. Someone write that down here. Length times width times height. But it is so much more than that, okay? And here's what I want you to see. If I was to go ahead and say that this is your length and this is your width, okay? Or reverse those two, because ultimately I want to make sure that this is my height. What we basically defined here is this. When we take length times width, this part right here, basically what we're finding of that rectangular prism is the base area. And so I'm going to go ahead and write that down here. Volume is equal to base area times the height of the prism. Okay? And that's actually going to be the formula that we are going to use. Length times width times height, great formula, can use it on lots of rectangular prisms, but we need more than that. Because some of them, as you see in the second one over here, is not going to be a rectangular prism. So, as we look there, if I go ahead and plug that in, the base area is 24 by 20, and the height is 10. And if you plug that into your calculator, actually I shouldn't say approximately, this will be exactly, you should have 4,800 centimeters cubed, okay? Now, we're doing area now, or volume now, okay? It's not just two dimensions like area is, it's three-dimensionally, and so as a result, you need to make sure that you label it correctly. Later on this week when you take a quiz, I will be watching for your labeling of your answers. Make sure you label it correctly, okay? Are we working with volume or are we working with area? And for your quiz, it'll be area. For right now, we're moving into volume, so make sure you label it as volume. So if at all I get in a hurry and accidentally label it incorrectly, I apologize. But again, make sure that you're paying attention to that. Now, let's go ahead and write that formula up above, what we're going to be using. Big B times H. Remember, capital B means base area there as we work through these problems. Now I'm going to skip the second one here for just a second. And I want to go down to the third one here and look at this one. How do we find the volume of this figure? Well, first of all, you're probably going to want to ask yourself, what is the base of that triangular prism? And we've talked about this several times already. The base is the triangle. So as a result, I'm going to have you go ahead and shade in that base. Okay, and even if you want to go ahead and make a note, here's my base. There it is. Okay, and I have to find the area of that. Well, remember, you guys have known this for a while. The area of a triangle is 1/2 base times height. Okay? So what's the base of that triangle? Well, it's 6. What's the height of that triangle? Well, it's 10. Now the tricky part is, yes, this is the height of the triangle, but this is not the height of your prism. The height of your prism connects the two bases. And that length in this picture is that length right there. This length right here connects your two bases together. And so that will be a length of 5. And so, very simply, you just go ahead and simplify that up. Half of 6 is going to be 3 times 10 is 30. And then 30 times 5 is 150. And so like on the last one, make sure you label it as if it's a volume there. Okay, so 150 cubic meters. Okay, 150 of those big cubes that are each a meter by a meter by a meter are within that figure there. Okay. All right, now let's go back to number 2. As you can see, it is a triangular prism, and again, we are going to highlight the fact that these two faces are going to be our bases. There and there, okay? Now, what I'm going to do, I'm going to take this a step further, and I'm going to go ahead and show that equilateral triangle there as our base, okay? And so I have to find the area of that triangle there. So I'm going to take 1/2 the base times the height of the triangle. Well, we don't have that height, and so I'm sure you guys are pretty well trained by now to go ahead and drop a line down and see if we can figure it out. Most of you know really well that this is a length of 4, which is great, okay? And hopefully you recognize if it's an equilateral triangle, each of these angles have to be the same as well, so they're all 60. And if I drop a line down perpendicular base, it's going to break that angle in half. So we have a 30, 60, 90 triangle. Now, if you look up at the board in the front of the class, you'll notice that you have the 30, 60, 90 triangle rules. And so I'm going to go ahead and write that in here, that this length is going to be 4 radical 3. It's radical 3 times this short leg, okay? So I can go ahead and put that in there. But let's say that you are down the road, you don't have that formula right in front of you, and you're taking an ACT or some other standardized test, you're like, I forget how to do that. Well, remember, if I redraw this, you can always use trig within a right triangle, okay? You knew that this was 60 degrees, you knew that this was 4, and you knew that this was 8, and we had to find this length right here, okay? And so you can do several different things here. You can use your tangent function with these two, opposite and adjacent. You could use your sine function, opposite and hypotenuse. I'll go ahead and use the tangent function for right now. Tangent of 60 is equal to 4 over x, okay? Now remember, when the unknown's in the denominator, we can go ahead and cross multiply this, but eventually, remember, it's going to be 4 divided by, okay? And so as a result, I could actually use this volume equals 1/2 the base times the height. So instead of using 4 radical 3, 4 divided by the tangent of 60, okay? And then from there, multiply by the height of the figure. Now the height of the figure, again, connects the two bases here. So that's this length right here, and that would be 10, okay? So the area of the base, which is this, times the height, or the area of the base, which is the exact same, times the height, okay? So from there, let's see here, opposite. Oh, you know what? I just realized I did something incorrect. One of the mistakes of doing a video here. When I did this, opposite over adjacent, I did adjacent over opposite. Silly, silly me, okay? So we correct this, okay? And I'll go ahead and correct this as well. Okay. So opposite over adjacent. We cross multiply. 4 times the tangent of 60. Okay. Is going to go there. And so I'm going to put that in here as well. Times the tangent of 60. I guess those mistakes are going to happen when you only get 2 hours of sleep last night and your wife has a baby, you know. So running on a small amount of sleep, so I apologize about that. Okay, so from there, the total volume, if you calculate that out, should be 277.1 cubic inches. Okay, now never take my notes too seriously unless you double check it yourself. So if you want to, you can go ahead and pause your computer here and just make sure that I've done all the calculations correctly and that you are getting the exact same answer as I have. If you haven't, then you need to figure out what you have done incorrectly. Okay? All right, now, moving on to this next one, this rectangular prism, so to speak. It's actually a composite figure. We call it a composite figure because it's made up of several different types of prisms. And so if you look at this L-shaped prism right here, I want to make sure that we identify the base correctly first of all. So looking here, base area times height. The base is going to be this shape right here that I'm outlining, okay? If you don't know why, here's why. Remember, the base has to be both parallel and congruent to the opposite face. So we have that with that L shape. That L shape also touches all of the lateral faces, which would be all of these side faces here. This one that would be right there, that one, and the bottom right there. So that's why it's got to be the base. If you choose any of the other sides, they're not parallel and congruent, and they also don't touch all the lateral faces. So from there, the question becomes, how do we find the area of this shape? Well, we break it into shapes that we know how to find the area of. And so as I look at this, you can either drop a line vertically or horizontally. It does not matter. So I'm going to go ahead and move it horizontally. And so I know that I have a rectangle that's 2 by 4. Okay? And I'm going to add in the area of the other figure. Now, if you notice here, this length is 2 and this length is 4. So if this is 2, what does this have to be to have a total length of 4? Well, this would have to be 2 as well. Okay? And so this shape is actually a square. It's a 2 by 2 square. And the height, what connects the two bases together? Well, if I clear this off so you can see it a little bit better, you'll see that with this being the front base and the back base is back there, it's going to be that length right there, so it's just multiplied by 1. So it's not going to change your answer after you've added those two together. And so if we do that, we get 8 plus 4 times 1, which is just going to be a total of 12 cubic inches. Okay, and that's the volume of that figure right there. All right, let's move down to number 5, and I think you've got enough background information to go ahead and do number 5 on your own. So take a couple minutes here and see if you can figure out what that volume is going to be. Really try to understand and write out what we've been talking about over the last couple minutes. So pause your computer right now and see if you can work that out, and then double check it with my work up on the screen. Okay, hopefully you paused your computer and did the problem, and now we come back and we talk about it here. As I look at the dynamics of this composite structure right here, I have to identify the base to get the base area. The only two faces that are parallel and congruent, touch all the lateral faces, like the last problem, will be this front face. Okay, is it always going to be the front face? Absolutely not. It can change, but with this problem, it is the front face. So from there, like the last problem, I'm going to break this into different parts. Instead of doing a horizontal break like I did on the last one, I'm going to do a vertical break. Okay? If you choose to do the horizontal break, are you still going to get the same answer as I will? Yes. Okay, so don't worry about that. So if I do this, I know that this rectangle here is a 9 by 4 rectangle. 9 by 4. And I'm going to add in the area of this rectangle. Now I know that this length right here is 5, but I have to figure out what this length right here is. If this length is 4 and the total length is 16, that means that this length has to be 12. So this is a 5 by 12 rectangle there, and I'm going to put that down as well. 5 by 12. Now, what is the height of the entire prism? Well, again, the height connects the two bases. What's the distance between those two? It's going to be this length right here. And so that length is 12. Now if I simplify that, I have 36, 9 times 4, plus 60, times 12. I get 96 when I add those two together. And so multiplying those two together, you should have 1,152 meters cubed, or cubic meters, within that structure right there. Okay? And that is the volume of that prism. Okay? All right, now let's flip over to the back side, and we've got a couple of problems here on the back side that, again, they continue to get a little bit more difficult, and I just want to make sure that you walk through these problems either on your own and then double check it with me, or walk through it with me, because it'll be important you know how to solve the volumes of these figures when we get down the road to a test or quiz. So looking at the first one, we have a pentagonal prism that is not drawn to scale. Okay, so keep that in mind. If the dimensions, I tried to draw this as closely as possible, but if it doesn't look exactly right, you'll understand why, because I'm not a very good artist. Anyways, so volume equals base area times height. How do we find the area of the base? Well, in the pentagonal prism, the base is this pentagonal structure right here. And so I'm actually going to go ahead and draw the bottom three sides of that pentagon, just so we can see everything a little more clearly than doing it inside the figure there, okay? And if you remember, we're going to find the area of one triangle within the figure and multiply that by the number of triangles. So if I'm going to do that, I know that this base edge down here is the same as this one right here, 10 meters. So I'm going to put down 10, and I'm going to drop a line down perpendicular to get the height of this figure. Now that's going to leave me with a length of 5 here. Now how do we find the height? Well, we have to have the central angle, which again, remember, oh, excuse me. All right, and we're back. Let's see here. I was about to find the central angle here, and so if we do that, 360 divided by 5, remember there's 5 sides to the pentagon, so therefore the central angle can be broken up into 5 congruent parts. That gives me 72 degrees. If I divide that by 2, I get the measure of this angle, which is 36 degrees, okay? So from there, to find your height, I'll put that as the apothem because that's what it is. I'm going to use my tangent function of 36 equals the opposite over the adjacent. All right. Now from here, again, just reminding you, we cross multiply. Some of you already know the shortcut, which is great. Cross multiply there. All right, and then divide through by the tangent of 36 to get a by itself. Gone. Okay, so this is what the apothem's length is. Okay. So as we plug this in, the area of the base will be 1/2 times the base, which is 10, the whole base of the triangle or the base edge of the pentagonal prism, times the height of the triangle, which is this, 5 divided by the tangent of 36. Okay? And that's the area of the triangle. Now I'm going to multiply the area of that triangle by 5, and that will be the area of my base. That's the area of the pentagon. And then from there, multiply it by the height of the prism, not the height of the triangle, okay? We want the height of the prism. The height of the prism connects the two bases, so this pentagon to this pentagon, which ends up being this length right here, which is 25 meters. Okay? Now, if we plug that in, let's see here, we should get approximately, now this is rounded to the nearest tenth place, 4,301.2 meters cubed. They're cubic meters there. Okay? So that would be the volume of that pentagonal prism. Pretty big structure. Okay? All right, now, we're going to go down to the I-beam, and we'd like to know how much metal will be needed in order to reproduce this structure right here. Okay? Now, in order to do that, you'll notice here centimeters, 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 meters. Okay? Definitely want to change that in order to make sure that my calculations are correct. So, how many centimeters are in 1 meter? Well, there is 100 centimeters in 1 meter, so therefore there is 1,000 centimeters in 10 meters. Okay? So this is going to be a large number. Just keep that in mind as we work this through. Now, what would the base be within this structure? Well, the base is actually going to be this I right here. Not only is it parallel and congruent to the opposite I on the other side, it is also touching all of the lateral faces to meet our requirements of a base. So what I'm going to do, because it's best to be able to go ahead and see what's going on within this structure here, is I'm going to redraw that base. Okay, so that we can see everything that's going on. Now, in order to get the area of that base area times height, you can be creative with this. There's lots of different ways you could do this. I'm going to go ahead and I'm going to close off this rectangle right here. I'm going to find the area of the whole rectangle, and I'm going to subtract out the two rectangles right here, okay, to get what's left over, which is the I. Other ways you could do this, you could actually drop lines here and here and here and here and break it into 4 rectangles and a fifth longer rectangle. You could break it off horizontally here and here, have 2 bigger rectangles with a smaller rectangle in between. But that's how I'm going to do it. I'm going to complete the square or the rectangle and subtract out the parts that are missing. So in order to do this, the dimensions of the whole rectangle here would be 30 by what? Well, 20 plus 5 plus 5, that's 30 as well. So this is a 30 by 30 rectangle, okay? Now, I need to subtract out the area of this part right here, as well as this one right here, okay? Now, in the picture there, this is 12 and a half. You see that up here. That's what that's referring to, this length here and this length here. 12 and a half by 20, okay? So I'm going to subtract two rectangles, each with dimensions 12 and a half by 20, okay? Now that's my base area. The whole rectangle, a whole square, minus the two inner rectangles gives me the area of that base. Multiplied by the height of the figure, which is the distance between the two bases, which we've already proven to be 1,000 centimeters, okay? So from there, let's see here. If you plug that into your calculator, there will be 400,000 cubic centimeters within that structure right there, okay? Now you might be thinking that's a little outrageous, 400,000 cubic centimeters, but you have to imagine you're covering 10 meters here, which is over 30 feet, a 30-foot long beam, and so if you think about a centimeter by a centimeter by a centimeter, that's a pretty small structure, okay? In fact, most of us know inches better than centimeters, but if I go ahead and clear that. Okay, I can fit almost 16 and a half cubic centimeters in 1 cubic inch, okay? So again, it doesn't seem so outrageous when you think of it that way. And so 400,000 cubic centimeters would be needed of metal would be needed to reproduce that I-beam right there. All right, last two problems. You've seen these guys before. All right, we did surface area on both of them, but now we're going to do volume on both of them. And so I don't know if I've really stressed this very much, but volume is so much easier than surface area. There's not as many details to remember. It's a lot more straightforward. So as we look at this picture up here, what we're going to do is we're going to determine the volume of the entire structure and subtract out the volume of the innermost part. Now if you remember, a lot of you got confused volume and surface area earlier. You were trying to apply volume concepts to this structure here. So we don't want to do that. So again, I want to find the volume of the whole figure minus the volume of the inner portion right here that goes all the way down, and then we should be able to, once we subtract that out, get the total volume. So base area times height. The base area would be a 4x by 3x, that's the base area, times the height of the structure, which would be 5x. Okay, that's the volume of the entire structure before we remove that inner core. Now we're going to subtract out the base area of this rectangular prism, which is x by 2x. That's the base area, and the height of the inner structure is going to be this 5x right here. Okay? And that's it. Now you just have to simplify it up. Now, you guys have done pretty good so far. When we multiply these, 12x squared. I see a lot of you getting that correct. A little rusty when we start doing the algebra there, because we focus on more geometric concepts in this class, but don't forget that. X times x is 2x squared. Okay? And then from there we go ahead and just multiply together. So we have 60x to the third now. X squared times x to the first, we add exponents there. So 60x to the third minus 10x squared times x is going to be x to the third as well, so 10x to the third. And so in the end, we take the difference there. 50x cubed is the volume of that structure there, 50x cubed. Okay? All right, now I want to pause for a quick second here. Let's say you forget the rule of adding the exponents. What could you do to remind yourself as you're working through these type of problems say next year, maybe the year after that, or on an ACT test, I always try to tell you guys to write them out in expanded notation. For example, when we have x minus 5 squared, I tell you to write it out like this, because I really believe that if you see it, you're going to be able to do it, okay? Same thing's true with this. If I write out an expanded notation, what is happening here? Okay? I think you see, if this is x times x is x squared, if you take x times x times x cubed kind of becomes second nature. It's more understandable. And then the 12 times 5 obviously is 60. Okay? So just hopefully that's helpful. If not, delete it from your minds, but something to help you out with. All right, and we come to the very last problem. Like I said, this is the most detailed lesson for the week. And so looking at the very last problem, trying to do the volume of this prism, if you remember, we said that this face was the base of the figure, okay? And different classes chose to find the area of that front face in different ways. Now, I don't really care how you find the area of that front face. I'm going to go ahead and do something like this. Okay? But any way you want to find the area of the front face, as long as you do it accurately, that's all I care about. Okay? So I'm going to break it into rectangles here to find the area of this base. Now the area of this face right here is 4x by x. So that's 4x squared, and this is 4x squared. So I'm going to say that there are two faces, each with an area of 4x squared. Okay? And there's one face with an area of 4x by x plus 4x plus x. That's going to be a total of 6x. X plus 4x is 5x, plus one more x is 6x. So 4x by 6x. Okay. And I can actually, I might as well just simplify that. Well, no. We're going to do some simplifications over there as well, so I'm not going to worry about it. Now, the height of this prism, as we said the last time we covered this with surface area, remains 3y, the distance between the two bases. Okay? Now, I work this out. I get 8x squared plus 24x squared, and I'm going to multiply that by 3y. Okay? Now, 24 plus 8 is 32, so you get 32x squared. We don't add the exponents when we're at, if this was just 8x and this was just 24x, this would be 32x. You guys are pretty good at that. Don't change the rules just because we've got these intimidating exponents there, okay? The rules still remain the same, and that is, whatever the exponent is, it remains the same when we add them, okay? Now, when we multiply them, as we've talked, it does change, okay? Now, when I simplify this up, 32 times 3 is 96, so in the end, my answer is going to be 96x squared y, and that is your volume of that structure right there, okay? So, it took me a while to get through that video there, but hopefully you have a pretty good understanding of what the volume is and how I want you to go ahead and solve problems. So I want you to go over to the website, start working on those problems. When you get done, show the sub. If you've got them all correct, you can move on. If you don't, you need to continue to work on them, okay? You have to have those problems correct, because I am going to come back on Monday, and I'm probably going to give you a homework quiz, and I'm going to expect perfection, okay? I expect you guys to know what you're doing. It's a lot of responsibility to put the learning all on your shoulders, but that's what I'm doing this week. So good luck, and I wish you the best, and I'll see you guys later. Good night.